Welcome to the beginning of Module 4, Financial Mathematics. In this section, we'll introduce some of the basic ideas in financial math, including the dreaded taxes. Okay. One thing we need to get right off the bat is something that's been alluded to already, which is the notion of rate. You can think of this as just any quantity per unit measurement. So foot per second, something per unit temperature, anything per anything, miles per gallon. How do you calculate this? Well, the per is shorthand for division. So if you see per, you should be thinking division. Okay, so we're going to keep this in the back of our mind as we introduce taxes. So if you've never paid taxes, I envy you. It is essentially an amount collected on income or transaction. So it can be based off of your income that you earn through your job. It can be taxed on your property that you own. It can come from small goods that you purchase. It's typically derived as a percentage of the amount that you have. One way to sort of summarize how much in taxes you're paying is what's called your effective rate, which is the amount of tax paid divided by the principal amount. So for this principal amount could be your total income, price of the thing you're buying, the value of your property. So whatever object or instrument the tax is being derived from, the total value of that is the principal. And then the taxed amount is divided by that principal to compute your effective rate. Let's look at a few basic examples. So here we have three different pairs of principal and taxed amount. And we're just going to compute the effective rate. All we have to do here is a very simple division. You should always be thinking rate is a division. So let's take a look. So for the first one, our principal amount is $550, and our taxed amount is $73. So the rate is the amount taxed over the principal. So in this case, 73 over 550, which works out to be about 13.27%. Not so bad. Let's look at a more extreme example. Here the principal is just over 10,000, 10,071, and the tax rate is just under 2,500. So in that case, your rate is again computed as T over P. And this works out to be about 24.5%. Okay? So in this case, about a quarter of the value of whatever this is, your income, maybe you have a boat or something, a quarter of that value was taken for taxes. As a last example, we have something that maybe would be like the price of a house, $174,000, and the taxed amount is $18,611. So just once more, we do the division. And after putting this into a calculator, we get something like 10.7%. Okay? So these computations of effective tax rates are fairly straightforward. You just take the overall amount taxed and divide by the total value. It's more convenient than many other ways of representing rates of taxation because it summarizes the total amount of tax paid. In the U.S. tax system, for example, different portions of your income are charged at different rates that increase as your income increases. Instead of thinking about that, one should perhaps think of the effective tax rate, that is the total amount of tax that you pay. Another basic idea in financial mathematics is that of markup. So you can think of this in two ways. One is the markup, which is the amount added to the cost of a good or service corresponding to the per unit profit of the seller. So you can think of it as I create some object, like let's say I create widgets, and it costs me a certain amount to manufacture them. I then add something to the price so that I make a profit off of the production. A different notion is what's called the markdown, which says I'm going to take something off the price, for example, to encourage people to buy it. Maybe I have lots of leftover inventory from 2016 that I want to get out no matter what before the 2017 objects come in. So I'll reduce the price by a certain amount to encourage consumption. How they are computed is basically the same. The markup just says whatever the inflated selling price is minus the cost of production. For markdown, you take the old selling price and subtract the new one. Let's look at some examples. So for each of these pairs, we have an old price and a new price. We want to determine whether it was marked up or down, what the absolute markup and markdown is, that is just the difference, and then the relative markdown or markup. So relative equals absolute divided by original. So let's do it. So the original price was 600 and it was dropped to 500. So this is a markdown. The amount was 600 minus 500. So the overall absolute markdown was 100, and the relative markdown was 100 divided by 600. So something like 16.67% markdown. In the next example, the original price was 1,500, going up to 1,750. So in this case, we had a mark up because the new price is greater than the old price. The absolute amount is 250, and the relative amount is 250 divided by the original of 1,500. So again, about 16.67%. Here we have an example of starting at 25 and going to 15. So this is a rather extreme markdown. The absolute markdown was 10. And what is the relative markdown? 10 divided by 25. So this is about a 40% markdown. So this might be an example where the producer really wanted to get rid of whatever he had. So he slashed the price by 40% to encourage people to buy it. In the last example, we have the original price was $18,500 and the end price was $25,000. These are numbers that maybe could be like a reasonable car, like a mid-sized car. Maybe the cost of manufacture was $18,500, and they add something to mark up to make a profit. So let's compute how much that is. So this is a markup. The absolute amount is $6,500, and the relative amount is $6,500 over the original $25,000. So about 35.14% markup. So these are just some basic concepts that you should be familiar with for the CLEP. We'll move on now to more delicate notions of interest, including compound interest.